In our last video, we looked at how to graph one period of a cosecant function by first graphing the sine function. I'm going to show you one more example here. This sine function is a little more complicated, but it's really going to follow the same steps we did last time. So some things I want to note about this function, assuming that it was a sine function, the reciprocal of cosecant. I noticed that the amplitude is 3. I also note that this graph has been reflected since there's a negative a value, so I'll just make a note of that. I'll want to find the period of this function. The period of a sine function is 2 pi divided by the b value, which is 2 this time. So 2 pi divided by 2 gets us just a pi. And then finally I'm going to note at the end here that the whole graph has been moved down 1, so the midline's been moved down 1 space. And if you need help figuring those out, you can go back and watch one of my previous videos, one of my sine videos. So let's go ahead and graph that sine function, and then we'll take a look at how we can use that to find the cosecant function. So first thing, I'm going to go ahead and label the x-axis with the period. The period this time we said was pi, so I'll end this graph, this axis with pi, and I'll start here at 0 at the origin. I'll need the halfway point, which is pi over 2. And then half of the halfway point, pi over 4. Same thing we've always done to graph a sine wave or a cosine wave. And then this point would be 3 pi over 4. Okay. Let me go ahead and add in the midline. We said that that had been moved down 1, so I'm going to put a mark on my graph at -1, and I'll go ahead and draw this dashed line right here to show where my midline is. These graphs are going to have lots of dashed lines on them, so you may want to use different colors for this. My amplitude then was 3, so from there I'm going to count up 3, so 1, 2, 3, which would put me at 2 at the high end of the graph. And then I'll count down 3 from the midline, so 1, 2, 3, which puts me at -4. Okay, so let's go ahead and actually graph the sine wave now. And remember, the sine wave has been reflected. So my original point for a sine wave is going to be at the midline, so right there. Since it's been reflected, I'll then go to the minimum value. Normally sine goes increasing, goes up. Next point would be back at the midline. I'd be at the high point of my graph next, and then I'd finally finish at the midline. So when I go to graph the sine function, I'm going to do this, but I'm going to use only a dashed line because, again, the sine function is not really the one I'm graphing. I want to graph the cosecant function. So the sine wave will help me do that, but I don't want it to be the actual graph, so I'll just do that dashed. Okay. Now, last step before I actually graph the cosecant is I want to add in the asymptotes. The asymptotes are going to occur every time your sine wave hit the midline, so not necessarily the x-axis like we did in the previous video, but where that line hits the midline. So at those locations, that's where our vertical asymptotes will occur. So there's going to be one at 0, at x equals 0. There'll be one here at pi over 2. There'll be a vertical asymptote. And finally, there'll be one here at pi, all the locations where the sine wave hit the midline. Now I'm able to actually graph the cosecant function because we haven't actually graphed any part of it yet. Your cosecant will be a series of u's trapped in between those vertical asymptotes. So one of them will be down here. They'll both share this point. Pi over 4, -4 is a point on both graphs. The low point of the sine wave is the high point of that cosecant piece, and then finally there'll be another piece up here. Again, it'll, oops, I kind of missed it, but they'll share this point right here. They'll share that point 3 pi over 4, comma 2. So there is one complete period of this cosecant function. It consists of the 2 u's, and of course those would just repeat forever in both directions.